Good morning. I had a student ask me a question about question number 4 in the homework. And it tells me there's 1,000 teachers. I have 500 men and 500 women. They're promoted from the teachers. There are 30 administrators and 60% are men. If administrators are selected randomly, what's the approximate probability that the percentage of male administrators will be 60% or more? So one of the things I want to talk about is now as we move forward and we use more StatCrunch and we hit view an example, it's going to be a little bit more difficult. But when I look at this and it tells me that I can find this is approximately normal, that's what the capital N means, with a mean of P and a standard deviation of P times 1 minus P over N. And I noticed that they check all the conditions. We were told it was random. Each of these is independent. There's a large enough sample, and it comes from a big population, at least 10 times bigger than the sample size. The sample size was 30 administrators. 10 times that is 300, and I have 1,000 people I'm pulling from. They go through that analysis here. I just want to make sure you know that using this is still helpful. Remember, the sampling distribution follows this. This is about the male teachers because it's asking the probability that 60% or more are male. And so the mean is 0.5 that was given to us in our problem. It looks like in their problem they have 50 administrators. Ours would be a 30 here. We do not need to calculate the z-score because we're going to use the normal calculator. Looks like they do that for each part. So let me do part A. Let me get my calculator out. So this is going to be approximately normal, and so I'm going to want to open up StatCrunch. I'm going to use the normal calculator, so I go Stat Calculators Normal. Let me see if I can see both of these. So the first thing is I need the mean, which is going to be 0.5. I need the standard deviation, which is going to be 0.5 times 0.5 divided by 30 and the square root of that. And you can try that, and I get 0.0913. I want the probability. It will be 60% or more, so greater than or equal to 0.60. And it looks like, oh, I'm so sorry, I just clicked into my email. It looks like I get 0.136, 1.137 when I round to 3. Let's see how we did. And we got that one right. I think you'll be able to follow that for the next parts. If you're not, please let me know, and I'm happy to make more of a video. Thanks.